Okay, so I'll kick off. Thanks very much everyone for coming. I know it's the last day, it's into the last few sessions, so I appreciate everyone staying around as long as you have. It's been a tiring 3 days, I know. So I'm going to talk about Google's data collection on Android. It's quite an interesting topic, I think. That's why I'm talking about it. It's also subject to sort of very vociferous and partisan opinions. So hopefully I'll be getting to some of the truth of some of the claims out there. I feel like I'm uniquely able to speak about this. I am working for Zebra Technologies. You may, in fact, I recognize some of the faces in the audience here. We've got a booth just out there. We're an OEM for Android, ruggedized Android devices. And we have a feature called GMS restricted. We ship all of our devices with GMS enabled, but a number of our customers have privacy concerns with what data goes from the Android device to Google servers. And so we have this feature to disable all of the GMS apps and services on the device so that we can allay their privacy concerns. But obviously, we need to understand a little bit more about what's going on so that we can assure our customers that, hey, yes, we have stopped everything going across the wire. So hopefully I can come up a little bit from the detail, explain sort of maybe the testing methodology so you guys can do some of these investigations for yourself, and then we'll go back down into the what I have found and what has been found out in the industry as well in some academic studies on this topic. I put this image in. We normally give away these little zebras, but unfortunately we didn't have any today, so sorry about that. That was a bit of a tease. So I did a Google search for Google data collection on Android, and this was, no lie, the top result. I was doing this in the UK. It's a Guardian opinion article, and the headline is like, "Are you ready? Here is all the data that Google have on you." And I did this to try and illustrate that there's two schools of thought here. There's the alarmist school and the ameliorating school. If you look at some of the headlines in this article, from what is admittedly an opinion piece, but the Guardian is considered a reasonably trustworthy news source in the UK, the headlines were a little bit alarming, like Google knows where you've been, or down the bottom here, Google knows everything you've ever searched. I mean, it's probably no secret to everyone in this room that if you search for something, it's in search history. This is maybe written for a little bit of a more basic audience. And so I went into the comments section of this article, and again, I haven't doctored any of this. The top comment was the exact opposite point of view. Essentially, I'll paraphrase rather than read it, and he's saying, I actually did this. I went in and saw what Google had on me, and there's nothing there. I did Google takeout. You guys are just trying to worry people with these headlines. But then he got some replies from Tompa2 and Just Another Flyboy. They really didn't agree with his point of view. And in fact, it even gets into all caps shouty with Mr. Joseph Blogsworthy down here saying the NSA are on you and they're going to capture everything. So, but he doesn't actually, once you get past the irrational shouty all caps, he makes a reasonable point. Maybe they're collecting this data and just not telling you about it. It's all a matter of trust. And that's where maybe you have to get in and do some investigation yourself. So let's assume we want to test what data is going across the wire from our device and heading up to Google servers. So we need to look at what variables there might be in the system. So some of the obvious ones, you've got what version of Android, is it Nougat, Oreo, even like the API levels maybe, and then what device are you running on? Location, really big. I mean, there was headlines recently that Google was sharing location. So what are the location services available? Are you doing any searches? And the variables kind of stack up at this point. And I put this together just off the top of my head thinking, what would I need to control? Things like the setup wizard, whether you agree to diagnostics, analytics, are there multiple users on the device? Should the device move? Obviously, if it's sending the location back, then a moving device is maybe going to send more data. The individual GMS apps like Chrome and the GMS keyboard have their own analytics agreements. Do you agree to those? Do you enable other apps on the device that might be using location? And again, these are all unique and just stuff that I had to consider when I did my own test. But do you use Play Protect? Do you go outside of your house and go near beacons or go near additional Wi-Fi hotspots? I can probably read it here, a bit less awkward. But yeah, so there's lots, and I stopped trying to think of new ones when I got to the end of this list. The point here is that even when you're reading some of these academic studies, it's difficult to know exactly the test conditions that the devices were under, and there's so many different ways of using Android devices that it's impossible to really come up with a single answer to how much and what is this data that's going across the wire. But let's try. Let's try and come up with some test methodologies. So before we try and answer what is going across the wire, it's probably an easier question to say how much is going across the wire. So this is a common question, particularly in regions where data is maybe on a limited plan. They want to restrict or understand how much GMS services are running. You can actually call into, as an Android API, the Network Stats API, and it will tell you, on the right there, for example, this particular package, it's ordered by UUID, is using, in the test here, it's 6 megabytes of received data over a combination of Wi-Fi and cellular. So this information is available. There are thousands of apps. I wrote my own one because, in all honesty, a lot of these apps look a little bit dodgy. You download them, you get loads of ads come at you. So it's obviously the kind of person that's trying to understand what is running on their device. There's us who are really techie and want to understand this, but there's also the grandmothers in Illinois who are just a little bit worried. They've got their Task Killer app and they've got their Data Logger app, and yeah, these are the subjects who are maybe subject to some of those ads. But anyway, so I've written my own. It's open source. Feel free to download it if you want to do this. How much data is going across the wire? But that only gets you 10% of the way there. The more interesting results are what is going up to Google. So you set this, got this little setup here. So we've got the device on the left-hand side, and it's going to be communicating with Google. I'm doing this at home, so everything's on this 192.168 address. So in between the device and the outside internet, we're going to be running all of the traffic from the device over a VPN tunnel, and I'm running a VPN server on my Ubuntu laptop here. And I should say, I am not a network engineer. I'm a software developer for Zebra, for Android devices, so I really built what I had done on some blogs that I'd read online, but I have documented it up the top there. But once we've got all of our traffic going through a VPN and we're controlling that, we can see all of the traffic going across, we're able to create our own test certificate. So this is essentially a man in the middle. We're not attacking anything, we're kind of snooping. We create our own certificate authority. The tricky bit is often to get the Android device to trust that certificate authority. Luckily, I was testing on a Zebra device. We exposed an API where you can add your own certificate authority, so that saved me having to try and root the device, but you could, of course, root your own Android device. And then I create this test certificate pretending that I'm reporting from google.com. Obviously, I'm not making any of this public. I'm just doing this for my own testing, so hopefully it's all legal doing this. But at that point, obviously, I know my own private key, so I'm able to use Wireshark to capture all of the packets off of the server and decrypt and understand exactly what that traffic is. So having got everything set up and running, I was quite excited at this point because, like I say, I'm not a network engineer, but I did manage to get to this point where I am reporting from my own authority. My name is Darryn, so it's the Darryn authority. I'm not very imaginative. And we're going to google.co.uk. I'm UK-based, you can tell by the accent, to an HTTPS site, and Chrome trusts me. So this is good. At this point, we are able to intercept the communication. And just as a test, I don't expect anyone to read this, but I searched for the word pie on Google, and I got this back here. A pie is a baked dish, which is usually made of pastry dough. I mean, this was a year ago when Android Pie was coming out, and it was very exciting. I thought it would be a relevant thing to test. So proof of concept, I've got end-to-end. So I want to now dive into what I found out as the topic of the talk. What data is is Android sharing to Google about you? So let's go and have a look. So I mentioned variables earlier on. So the test conditions I was running under, I had an Android Nougat 7.1 device at the time. Like I say, so about a year ago I was running this. I kept the device stationary but plugged into power. I didn't want it to be subject to doze mode. I wanted it to have every opportunity to upload data should it choose to do so. I did add a Gmail account to the device. I factory reset it so there was nothing else on the device. And I went through the setup wizard and just said yes to everything. So it should be, in theory, I gave it permission to share analytics, location information, backups, again, should it choose to do so. And then I left the device overnight. This is like probably a 12-hour test. I should have written how long I tested it for actually on here. It's a single test, so don't consider this as representative of I've run everything over a month and I guarantee this is what your device is going to reliably do. This is a single OEM's device, but just to give you an idea, so blue is packets that were going to Google servers generally, and I'm just counting the packets here in Wireshark. I'm not trying to count the HTTP traces, and I'll get into why that is in a future slide. But the yellow is data that was going back to Zebra analytics servers. So your own, depending on what device you're testing on, your own OEM may be sharing different data with their own analytics. Maybe Samsung is sharing more, maybe Sony or Huawei are sharing more data. But this was the pie chart of Zebra versus non-Zebra data. So just going a little bit deeper into which API endpoints Google were receiving this data, it is, well, I won't read all of those out. When I was explaining this to our system test team, the first question they asked was, how do I know if a URL is a Google URL? I thought that was pretty obvious because most of them say Google in there, including the 1E100.net, which I thought was quite clever. It's like a mathematical Google. But in most cases, this is pretty obvious, but you can just go online and there's like who is and type in the URL and find out who owns those domains. So the actual traffic, I thought, well, this is really interesting. Now let's have a look at what I can see in some of these HTTP strings. I managed to capture this over the wire. This was an upload to lock.m.api, so I assume this must be a location update. And it's at that point that I realized that, probably obvious for 80% of the people in this room, that although I was clever and decrypted the traffic, I had not decoded the traffic. So the location object was still a binary object, so I didn't know exactly what was going up. So I thought I'll come back to that, and we'll come back to that in a later point in this presentation. More interesting, though, was another capture I found. I was from the quick search box, which is the package name for, this is Nougat, don't forget. So these things do change from Android version to Android version. So quick search was the Google search assistant, or the widget on the home screen. So my device was sharing an Android ID, and there's more than one of these Android IDs. I don't believe this one is permanent, fixed to the device, but it is an ID nonetheless. When you first register your Android device, it was sharing my email address. I've adopted that to be a fake email, but there was an email there, the SDK version, and the country. So I thought this was a little bit unusual that it was sharing this stuff, but like I say, I had agreed to all of this in the setup wizard. So I'm trying to present facts here. I'm not trying to present a biased view one way or the other. And again, it's a point I'll come back to later in the presentation. But it's at this point that I really hit a little bit of a roadblock when I came up against quick data, QUIC. This is a UDP protocol that I'd never heard of, and it's probably quite popular. I wasn't a network engineer, I'm still not, and many of you may be, but I pretty much had to throw my hands up at this point. This is a secure mechanism that Android is using, at least in 7.1, where I was testing to communicate traffic. I could not turn it off. There was no option. I'm sure I could have got in contact with our device image team, and they might have been able to tweak Android somehow to turn it off. But even though I knew the private key, any attempts to decrypt this quick data was met with a little bit of face palm on my point. And I'm because I'm not a security engineer, so I wasn't able to type this in. So I didn't give up at this point. I thought, well, what else can I do to sort of give some answers in this presentation? So I thought, well, what else has there been done in not just in the community, but in the academic community as well? And there's been a lot of previous studies on this exact question of what data Google is sharing, Android is sharing, with Google. So there is a latest paper from 2018 that I'll cover in the next slides, but these were some of the references, and I went back and read some of these of past studies that have taken place. And a couple of observations on these. First of all, this paper here is from Oracle, so with everything that went down with Java and Oracle and Google, is that an unbiased paper? I don't know. Again, I'm not passing judgment. I'm just saying I would question that if I was trying to read this and put together my own opinions. But down here, this man whose name I will not attempt to pronounce from Sweden, 2012. So it's a little bit long in the tooth now. It's getting a bit old. But very important observation was that the Android operating system was passing anonymous IDs along with device IDs, such as the MAC address and the IMEI number. Obviously, nowadays, MAC addresses are pseudo-randomized when Android connects to APs, and your application is not able to get the MAC address. But back then, MAC addresses were a bit more ubiquitous and used to identify devices. And 2012 would have been an older version, but yes, interesting find, and we'll see some of that repeated. But I did want to just point out that although I was really proud of the tests that I'd managed to do and put together myself, many of these papers had already done this test. These are the screenshot from old Lasse Oliver, 2012. He had managed to connect through this man-in-the-middle technique, and even the image to extract the data from the VPN off the device. Interestingly, this is the 2018 study talking about UDP. So I got quite excited at this point. I was like, yes, he's done the work for me. He's managed to decrypt this quick traffic. He was testing on Marshmallow, though. In fact, let me just advance the slide. He was testing on Marshmallow. So that may have been the reason maybe Quick only became a communication protocol that was introduced in NuGet. So this is the most recent paper on the topic. I'd definitely advise reading this. It's been made available to the public. Some of the data collection sources are a little bit obvious, like he used the takeout and my activity of Google just logging in. But the most interesting one for me, and I'm sure for many of you as well, was the same technique I described earlier, where data was intercepted in between the Android device and Google domains. So this guy has a PhD, so he's probably a little bit better than me with my BSc swimming certificate, and he was testing on an Android 6 device, at the time, most popular device, and indeed, when I looked up a couple of weeks ago, putting this slide together, it still has a 16.9% market share. So it was still the most popular OS when a couple of weeks ago. So still, so this is relevant information which I'm presenting and which was in the paper. It distinguishes between active and passive collection. Obviously, active collection, we all know when we're typing in a Google search that Google has to search for us. It has to sort of know what we want to do, but it's the more passive collection that maybe people are more concerned about, and that raises these headlines where we don't know what data is being shared, and even like us techies don't know sometimes, which is obviously the public are going to know a little bit less than the technical minded. So let's just look at some of the results in this paper. I won't go into detail. It's not a very long paper. It's only about 10 pages long, including the techniques they used to investigate. But the first finding was that those number of passive collection events outnumbered the active collection events by around 2 to 1, and they had a much longer table, but I just extracted some of their table results here. Things like when they listened to Google Play in the morning, then they noticed that the location was being shared with Google when the person requested their music. So that's a finding. Again, I'm not looking to present opinions, I'm looking to present data. And dining interests were collected when a destination was entered into maps. If they were searching for a restaurant, maybe the preference of what that restaurant served was uploaded. So that was the first result. The next one was, in fact, the quotes, anything in quoting italics, I've taken directly out of the paper because I'm not trying to misrepresent anything. So they said it is hard for an Android mobile user to opt out of location tracking. And I would agree with that. So as someone that's worked with Android location quite a lot through my current employment, I know, and this is the list that I came up with, of the ways that Android can determine a device's location. And this is a real positive because it provides real value, especially when you're trying to navigate in an unfamiliar city and GPS just isn't cutting it because you're underground. I could tell the story of my in-laws when they landed at Boston and they had a GPS receiver and it was useless because it's all tunnels when you land at Boston Airport. But when me and my wife did the same, we were fine because we had a phone and location services and it knew exactly where we were. But yeah, location's easy to turn off. All the headlines most recently that Google was tracking you was because you can turn location off, but that's only turning off part of this. And I kind of knew that, but the public would just hear location being turned off. You assume everything's being turned off, and maybe that is a more sensible assumption. I don't know. It's not for me to judge. The other finding. If I had a criticism of this paper, it was they make statements like, during a short 15-minute walk through a residential neighborhood, they find 100 unique SSIDs. But they don't say whether that residential neighborhood is downtown Manhattan or downtown Poughkeepsie or wherever else, downtown UK, Basingstoke or somewhere where I live. There's just 100. So is that a high number? I don't know. It sounds pretty high, but maybe it's low for some places. That's a finding. Anyway. So interesting, actually, the location that's being shared back, so we do have some of the location objects on subsequent slides, but just in terms of number of requests per hour, they were seeing, and this is on a stationary device, very similar setup to what I had earlier on when I was talking about my test. This was a device that was left in an idle state, and it was sharing its location. Around 35% of HTTP requests back to Google were location, and they were seeing in total about 40 requests, so 35% of 40 is what, like 13, I guess, location requests an hour. Similar to me, though, they were only running their tests for a 24-hour period, so don't take any of this as the rule that this is going to be every time on every device. I forgot to mention, actually, they don't even specify which device they were testing on. So I'm not criticizing the paper because that whole list of variables I mentioned earlier on, it's not possible to list all of these sometimes because there's just so many of them and they're changing with every version of Android almost. So here was another finding. I'm just picking out the findings that I found most interesting. So we are probably all familiar with, there is an API on Android that allows you to determine the activity of the user. And this even works offline. It requires Google services. It's through the Google API client, I believe, activity recognition. And you can see if the user is driving, walking, running even. I did try running around my house and it detected that. But did you know that those activity readings are also being shared with Google, which according to the study they are, which I thought was quite interesting. The confidence, I would presume this is being done to improve machine learning algorithms. I don't know, but I'm here presenting facts. So there's a fact that those are being shared. Some of the more curious findings in the paper were these observations that the check-in upload was observed 2 times in a 24-hour test. Again, this is on Marshmallow to confirm, and this contained the MAC address, the IMEI, the Gmail of the tester, and the serial number of the device. And then there was a second packet that was observed, I believe this was observed a few times as well, where a Google Services Framework ID and a Google Advertising ID were both detected in the same upload. And I haven't, to present the findings of the paper, they have said that this gives the company, this gives Google the potential to de-anonymize any data sent. So it's not obviously you can't make any assumptions on whether that data has then been used to de-anonymize. It just merely stops that it has the potential to de-anonymize some of that data. I'll just finish going through the findings from that paper. So they then did another series of tests on a moving device, and their determination was that a moving device showed about 1.4 times the number of location requests being shared, which I thought was a bit lower. They were presenting this as, hey, look at this high number of requests being sent, but I would have thought it was more than 1.5 times more. So just as a comparison, this is in the number of requests, and these are HTTP requests. Note how the bar scale is different on the moving compared to the stationary. So even though the bars look the same, it's the typical journalist I'm being here by having the same bar size but just a different scale. But the key is that the number, what am I saying here? So they had a lot more ads and ad-related uploads, a lot more, so location was numerically more overall, but as a percentage it was less on a moving device because the advertisements, so they were using like in-app ads and they were actually using the device in what they called a typical usage scenario, and they were doing they got some other papers that had analyzed how a typical user uses their device, and they were doing those actions, and then obviously because they're using apps that have ad analytics embedded within them, and many ad domains are owned by Google, then that's why they were seeing a huge increase in ad traffic compared to a device which was stationary with no apps being loaded. In conclusion, and this is the conclusion of the paper, the main conclusion was that a major part of Google's data collection occurs while a user is not directly engaged with any of its products. The magnitude of such collection is significant, and just to paraphrase the last finding there is that there is the possibility to de-anonymize that data based on what the paper was observing. So a little bit worrying. I did want to add my own counterpoint to this observation, though, in that none of these studies that I read consider any of the value to the user. There's no mention, and maybe this is because they're only presenting facts and it's academic, but there's no speculation as to, well, why is that data being collected? Maybe it has a genuine purpose. You know, you get these runtime permission requests come up on your application. If they explain why the app needs location, you're a lot more likely to agree and understand. There are, obviously, if you read through the terms and conditions, Google will list out why it needs to have some of this data, but sometimes it's difficult to marry up the long T's and C's that none of us have ever read. They're quite easy to read, actually. I read them briefly about a year ago. But yeah, those long T's and C's with the actual reasons why an app might want to collect this, Google might want to collect this. There is an inherent assumption of nefarious purposes in everything I've read on the subject, right from that Guardian article right at the beginning where they literally have scary headlines, to even the academic paper where it's making factual claims, but you feel like you're not getting the full story. Like those SSIDs, where are you collecting them? What device are you running on? These kind of unanswered questions. In my mind, you know, I don't want to really lead to much speculation. But I did want to have, as an aside, there was an interesting, it really piqued my interest. The paper said that they observed a specific collection of location to this location endpoint. Do you remember the endpoint which I didn't decode because I didn't want to have to go into the source code and try and spend a couple of days doing this? But they'd done it. They'd reverse engineered it through the compressed protobuf message stuff I didn't understand at all. They'd done all the work, but they didn't actually put it in the paper. I was really disappointed. It wasn't in any of the appendices. I read through like 3 or 4 times. So my goal to understand exactly the format of that application binary, 315 bytes, did unfortunately not come to fruition. So that was a little bit of a disappointing end. But the next topic I wanted to cover in my presentation here is that's understanding the what, the how much, but exactly how would you go about controlling this data? And we work with many industrial partners that have privacy concerns and they want to control that data. So what are the advices we can give? If you search online, again, this is the first thing I do, is you get a lot of dodgy websites giving all sorts of advice for applications going all the way back to like Froyo to say, well, how do I prevent my data being shared. It's literally, most of it is turn this off, turn that off. Some stuff I know won't work. I don't know where they get the idea from some of these settings and what they do. But just to summarize some of the better sites, they say things like use a different DNS server, use a VPN, don't use Google Apps, disable app backup, turn everything off, don't use anything. And yeah, that will work, but you'll end up in a position where your device is much less functionally useful than if you were using these Google servers. I think we all know that it's the value that we're getting out of it is the reason why we're kind of happy to give up this information that's going across the other way. So no great solution other than turn everything off, which we all know. You could just turn your phone off if you really wanted to disable everything. There is always going to be this degree of trust. It's difficult to turn everything off because Android are always introducing new components, settings, behaviors. Having a step-by-step guide of disabling individual settings will never work because they're always changing the UI to make it better, and it has been made better. I'm trying to deliver a balanced opinion here. There's two approaches, though. There's a network-level approach and a device-level approach to stopping data escaping the device. The network level, there is no authoritative list of Google sites. Do you remember back when I had those two pie chart, or the exploded pie chart, and I had that list of 10 API endpoints? That was just my own test on a specific device, specific version of Android, left overnight. That was by no means exhaustive. You could block every IP address, which Google owns. There's about 8.9 million of them, 8.7 million, probably growing every day. You would, of course, be blocking every website hosted by Firebase if you did that, and there's an awful lot of those. Every Google service, every ad server, you'd be essentially rendering many of your devices useless. And you can only really do this if you're a network engineer controlling things like the proxy where devices are going through. Anyway, so for most customers, including most enterprise customers, this is a non-starter because they either don't have the capability or they produce a non-functional device at the end of it. What we have done, we've taken a different approach in Zebra Technologies, and we have this GMS restricted feature where we disable the GMS apps. So if you were to visualize what this might look like, all of the GMS apps like Gmail at the bottom there or the calendar app become disabled on the device. And we in fact, I think I have a demo on the next slide. We are at the booth just outside if you're interested in learning more of this, but just to show a quick demo of what this looks like on our devices. This is like 40 seconds long. Notice how this is a TC57. We have these at the booth. Has GMS devices available, being useful, providing value, but if you want to disable those, you can do so by scanning a single barcode with one of our value adds called Stage Now as part of your setup step of the device. And now notice the apps are no longer available. There's no Chrome, there's no Play Store, there's no music, there's no YouTube, there's no nothing. You would have to sideload applications if you wanted to install them. You could use an EMM that supports AOSP. You could use our own Stage Now tool to do that. But your device is now in a state where if you were to run that test setup I had at the beginning where it's going over the VPN, and this is what our system test team have done, we can verify that no data escapes from that device and goes to Google. So with that, thank you very much for listening. I've got a list of resources at the end of my presentation here. I do appreciate your time on the last day, getting towards the end of it. These slides, I believe, will be made available by droidCon, but I'll just leave them here a little bit longer. But I think I've got about 5 minutes for questions. So we do have a mic if there are any questions at this point, so please feel free to come up, or if not, I'll be outside at the booth after the presentation. So thank you very much, everyone, for listening.